Welcome back to Daily Dose of Space. Today, we're diving into one of the most important scientific achievements of the last few years, the James Webb Space Telescope's deep field images. These pictures are more than just beautiful. They're snapshots of the early universe, taken when the first galaxies were forming, and they've already forced scientists to rethink several major ideas about how fast galaxies form, how early stars were born, and how the entire structure of the universe evolved. In this episode, we're breaking down what Webb actually sees, what surprised astronomers the most, and what these early galaxies tell us about the history of our universe. No hype, no exaggeration, just real science presented in a way that makes sense. What the deep field actually is. The deep field isn't a single location, it's a method. Astronomers point a telescope at what looks like an empty patch of sky and let it gather light for many hours. For the Hubble Space Telescope, this was transformative. But Webb goes far beyond that. Thanks to its larger mirror and infrared capabilities, it sees light that's been traveling toward us for over 13 billion years. When Webb takes a deep field, it's capturing objects so faint and so distant that their light has been stretched by the expansion of the universe into infrared wavelengths. And that's exactly why Webb was built, to see what Hubble simply couldn't. The very first deep field released by NASA targeted a galaxy cluster called SMACS 0723. It wasn't chosen because it's special. It was chosen because the cluster acts as a gravitational lens. The cluster's mass bends light behind it, magnifying distant galaxies like a natural cosmic telescope. So Webb didn't just capture a normal deep field, it got a magnified one, revealing even smaller and more distant galaxies. Looking back in time. The idea of looking back in time isn't a metaphor. Light from some of the galaxies in the deep field has been traveling for more than 13 billion years. When Webb sees these galaxies, it sees them as they were shortly after the Big Bang, long before the Milky Way existed. This is possible because the universe is expanding. As distant light travels toward us, the space between increases, stretching the wavelengths into the infrared range. This redshift is the reason Webb's infrared instruments are so critical. It's designed to catch this ancient, stretched light. Some galaxies in the deep field are believed to be from just 200 to 300 million years after the Big Bang. That's incredibly early. Until Webb, most models suggested that few galaxies should exist at that time, and they definitely shouldn't be well-formed or bright. Webb proved otherwise. The early galaxy problem. One of the biggest surprises in the deep field was how many early galaxies appeared far more massive than expected. In standard cosmology, galaxy formation is slow. The earliest galaxies were predicted to be small, dim, and unstable. Webb found the opposite: bright, dense, well-structured galaxies appearing far earlier than predicted. This sparked what some astronomers unofficially call the early galaxy problem. It's not that the universe is older than we thought. The physics still checks out, but our models for how quickly stars and galaxies form might need adjustment. Some researchers suggest the early universe had different star formation efficiencies. Others propose that dark matter behaved slightly differently at early times, and some think the first stars were far larger, hotter, and more productive at forming heavy elements, which would lead to rapid galaxy building. It doesn't overturn cosmology, but it does show that we underestimated how quickly the universe organizes itself. The first stars and their signatures. Webb can't see the very first stars directly. These stars, called population 3 stars, formed without any heavy elements, just hydrogen and helium from the Big Bang. They would have been enormous, hundreds of times the mass of the Sun, and extremely short-lived. But but Webb can detect their fingerprints. Specifically, it looks for unusual ratios of certain elements, like extremely low amounts of oxygen and carbon, which suggests that the stars producing them were made from primordial material. Some deep-field galaxies show hints of these signatures. If confirmed, this means Webb may have found the chemical aftermath of the very first generation of stars. Webb versus Hubble. It's impossible to talk about the deep field without comparing Webb to Hubble. Hubble's ultra-deep field took hundreds of hours of exposure time. Webb produced a deeper, sharper, more detailed image in roughly half a day. The difference isn't just the mirror size. The infrared capabilities allow Webb to see through dust and catch older red-shifted light. Hubble showed us the universe's adolescence. Webb is showing us its infancy. Gravitational lensing reveals invisible galaxies. The galaxy cluster in the first deep field acts like a magnifying glass, bending light from galaxies behind it. This creates stretched arcs, duplicated galaxy images, and extremely magnified distant objects. This technique allows astronomers to study galaxies that would otherwise be too faint or small to detect. And in some cases, the lensing is so strong that Webb can observe star clusters individually. This level of detail lets researchers measure the size, age, and temperature of stars in galaxies more than 13 billion years old. That's extraordinary. Before Webb, no telescope could do this. Early black holes. Another surprising discovery involves black holes. Some deep-field galaxies appear to have black holes much larger than expected for their age. Normally, black holes grow gradually as galaxies evolve. But Webb detected signs that some early galaxies may have hosted black holes already millions or even billions of solar masses. This raises serious questions about how black holes form. Did some collapse directly from early gas clouds? Did the first stars produce unusually massive black hole seeds? Or are there entirely new mechanisms at work in the early universe? The deep field doesn't answer these questions, but it forces researchers to explore possibilities we hadn't considered. What's next for Webb's deep fields? The first deep field was only the beginning. Webb continues to target new regions, using longer exposure times and different filters to push deeper into cosmic history. Future projects aim to capture galaxies from only 100 million years after the Big Bang. Eventually, Webb may help scientists build a timeline of galaxy formation, from the first stars to the first large-scale structures. And with each deep field, we get a clearer picture of how everything in the universe came to be. The James Webb Deep Field images are more than snapshots. They're windows into the earliest moments of the universe, showing us how galaxies formed, how stars were born, and how cosmic structures grew. In just a short time, Webb has reshaped our understanding of the cosmos, and it's only getting started. Thanks for watching Daily Dose of Space. If you want more deep dives like this one, subscribe and stay tuned for the next episode.